Before we dive in, I've got something for you. If you're studying for the A.R.E, you don't need to figure it out alone. Inside my free resource hub, you'll find study guides, resource guides, pop quizzes, and other tools designed to make exam prep a whole lot easier. Head to dci.beyoungdesign.com/resources or check the link in the show notes to grab it now. It's completely free. All right, enjoy the show.
Hey friends, welcome back. Today we're diving into electrical. Yes, that electrical. The one that makes a lot of A.R.E candidates want to run the other way. And look, I get it. Unless you've worked in MEP or had a really good building systems course, electrical feels abstract. It's wires, amps, watts, numbers that don't feel tangible. And honestly, most people study it the wrong way. They try to memorize formulas, cram in random conversions, and just hope it sticks. But here's the thing. The exam isn't testing whether you can be a walking calculator. It's testing whether you understand how these systems show up in a real project and how the design decisions you make impact them. So today I want to share 3 things most candidates get wrong about electrical and what to do instead. Okay, so the first mistake is thinking you can memorize your way through this. Almost everyone has heard watts equals volts times amps. But what does that actually mean? Most people can't explain it, and that's where they get tripped up. Here's the way I think about it, and I want you to literally picture this. Imagine a pipe full of water. The voltage is the pressure in the pipe. The amps are the actual water flowing through, and the watts? That's the work being done, like a water wheel spinning at the end. So if you can remember that image, it's way easier than trying to force the equation into your head. And this isn't just theory. Let's say you're looking at a cut sheet for an air handler and it says 2 horsepower motor. If you've made the connection, your brain immediately says, oh, 1 horsepower equals about 746 watts, so this thing is drawing about 1,500 watts. That matters when you're sizing systems or thinking about the load on a panel. The takeaway here is don't just memorize the numbers, learn how to apply them. The A.R.E loves to throw you into scenarios where you have to connect the dots, not regurgitate a formula. All right, number 2, a lot of candidates get tripped up on single-phase versus 3-phase power. And honestly, I get why. It sounds technical, but it's actually pretty straightforward if you tie it back to real buildings. Single-phase power is what you've got in your house or a small office. Think 120 volts for your toaster, 240 volts for your dryer, everyday stuff. But the second you step into a bigger building, a hospital, a big box store, or a high-rise, you're going to see 3-phase power. It's smoother, more efficient, and way better for running big motors and heavy loads. Here's a quick exam rule of thumb. Small buildings, single phase. Large buildings, 3-phase. So if the question says you're designing for a commercial building with big HVAC systems, and they want to know what kind of service is typical, you can bet the answer is 3-phase. It's that simple. And once you see it this way, you won't overthink it. Okay, last one. And this is one of those things that candidates always forget. Efficiency and demand. We tend to think only in terms of how much energy a building uses. But utilities also care about your peak demand. Here's an example. Let's say your building hits a peak load of 50 kilowatts for just one afternoon. Even if it's only for 15 minutes, if the utility charges $10 per kilowatt, that's a $500 demand charge on your bill. One peak, one moment, and boom, there's the cost. That's why engineers stagger when equipment starts up. If everything kicks on at once, you spike demand and get slammed with charges. And as architects, why does this matter for us? Because when we talk about efficiency, LED lighting, smarter HVAC choices, it's not just about being green. It's literally about designing buildings that are cheaper to operate and more sustainable long-term. On the exam, if you see a question about cost, energy use, or load management, remember, efficiency plus demand go hand in hand. So let's wrap this up. The 3 things most candidates get wrong about electrical are memorizing formulas without understanding them, mixing up single-phase and 3-phase power, forgetting how efficiency and demand actually play out in real projects. If you can get those 3 straight, you'll walk into PDD way more prepared. And here's the bigger picture. Electrical doesn't have to be this scary, abstract thing. When you tie it back to real-world examples and patterns, it actually starts to click. If this episode was helpful, just know this is a fraction of what we dive into inside the ABC Club. Members get full-length lessons, explainer videos, and real accountability to help them not just study, but actually pass. So if you're ready to stop piecing it all together alone, come join us. Thanks for hanging out with me today, and until next time, happy studying.
Thanks for listening today. Hey, remember, you've got free resources waiting for you at dci.beyoungdesign.com/resources. And when you're ready for deeper support and to come hang out with us, join us inside the ABC Club and ABC Club Premium, where you are going to get the help you need to pass your exam and actually enjoy the process. So don't let another week go by without moving forward. Take action. You got this. Check the links in the show notes and join us inside the club.